Good day. Today we are going to discuss about the standard normal distribution. And under this, we are going to learn about the normal curve and its properties, the standard score, and the areas under the normal curve and the application. The normal distribution is also known as the bell curve or a Gaussian distribution, named for the German mathematician Carl Friedrich Gauss, 1977 to 1855, who derived its equation. Normally distributed variables are distributions that are bell-shaped. A normal distribution is a continuous, symmetric, bell-shaped and distribution of a variable. Summary of the properties of the theoretical normal distribution. It is bell-shaped. The mean, median, and mode are equal. A normal distribution curve is unimodal. The curve is symmetric about the mean. The curve is continuous. The curve never touches the x-axis. The total area under a normal distribution curve is equal to 1 or 100%. The area under the part of a normal distribution that lies within one standard deviation of the mean is 0.68 or 68%, within two standard deviations about 0.95 or 95%, and within three standard deviations about 0.997 or 99.7%. Finding areas under the standard normal distribution curve. Example. Find the area to the left of z is equals to 1.99. So based on the z-score table, the value of 1.99 is 0.9767. Hence, 97.67% of the area is less than z equals to 1.99. Find the area between z equals to 1.68 and z equals to negative 1.37. So the value of 1.68 is 0.9535 and then the value of negative 1.37 is 0.0853. So the area between the two z values, we are going to subtract the 0.9535 to 0.0853 and the answer is 0.8682 or 86.82%. A normal distribution curve as a probability distribution. Example, find the z value such that the area under the standard normal distribution curve between 0 and the z value is 0.2123. So the value in the left column is 0.5 and the top value is 0.06. So the positive z value for the area z is equals to 0.56.
The normal distribution. The normal distribution is the continuous distribution which becomes the basis of the entire theory of statistics. This is also known as Gaussian distribution, which is named after Carl Friedrich Gauss. Properties of normal curve. The peak of distribution lies at the center of curve, represent the mean, mode, and median. The curve is continuous. The curve is symmetric about the mean. The tails of the curve are asymptotic with the horizontal axis. The total area of the curve is equal to 1 or 100%. Approximately 68% of the area lie between the standard deviation from the mean. Approximately 95.5% of the area lie between two standard deviations from the mean, and approximately 99.7% of the area lie between three standard deviations from the mean. The standard normal distribution. Any normal distribution can be converted into the standard normal distribution by solving for the c value. And the c value can obtain by the following formula. C is equal to the value of any measurement minus the mean of the distribution over the standard deviation of the distribution.
Example, on a midterm exam in statistics, the mean is 55 and the standard deviation is 10. To find the c-score of the student who got 55, with the use of c formula. C is equal to the value of any measurement minus the mean of distribution over the standard deviation of the distribution. Z is equal to 60 minus 55 over 10 is equal to 60 minus 55 is 5, then copy the 10, then 5 divided by 10 is equal to 0.5. Therefore, The C-score of the student who got 55 is 0.5. The corresponding row score of a student who has C-score equals negative 1.5. To find the value of any measurement is equal to the standard deviation of the distribution multiplied to the C-score plus the mean of the distribution. The value of any measurement is equal to 10 times negative 1.5 plus 55. Since 1.5 is negative, so it would be negative 15 plus 55 is equal to 40. Thus, the corresponding row score of a student who has C-score equals negative 1.5 is 40. In standard normal distribution, the mean of the distribution is always equal to 0, and the standard deviation of the distribution is always equal to 1.
Areas under the normal curve. Find the area under the normal curve between 0 and 1.63. The answer is 0.4484 or 44.84%. For other example, find the area under the curve between 1.02 and 2.11. Therefore, we will get 0.4826 minus 0.3461 is equal to 0.1365. Find the area under the curve between negative 2.19 and 1.67. Add the areas. 0.4857 plus 0.4525 is equal to 0.9382. The average age of motorcycle registered at the LTO office is 7 years or 84 months. Assume that the standard deviation is 20 months. If the random sample of 50 motorcycle is selected, find probability of the mean of their age is A. Between 60 months and 180 months. B. More than 120 months. C. At least 5 years.
A solution for between 60 and 180 months. To solve 60, C-score is equal to 60 minus 84 over 20 is equal to negative 1.2. Then find the value of negative 1.2 in the C-score table. The value of negative 1.2 in the C-score table is 0.3849. Then draw the curve under the negative 1.2. For 180 months, C-score is equal to 180 minus 84 over 20 is equal to 4.8. Find the value of 4.8 in the C-score table. The value of 4.8 in the C-score table is 0.5000. Shade the curve to the right. Then solve 0.3849 plus 0.5000 is equal to 0.8849 then times 100%, or it would be 88.49%. More than 120 months, C-score is 120 minus 84 over 20 is equal to 1.8. Then find the value of 1.8 in the C-score table. The value of 1.8 in the C-score table is 0.46407. Draw the curve under the 1.8, then shade to the right. So 0.5 minus 0.4641 is equal to 0.359. Then times to 100% is equal to 3.59%. For at least 5 years or 60 months, C-score is equal to 60 minus 84 over 20 is equal to negative 1.2. Find the value of negative 1.2 in the C-score table. The value of negative 1.2 in the C-score table is equal to 0.3849. Draw the curve under the negative 1.2, then shade it to the right. To solve it, 0.5 plus 0.3849 is equal to 0.8849 times 100% is equal to 88.49%.
Estimation and confidence intervals. Estimation is a method to estimate the value of the population. Parameter from the value of the corresponding sample statistic. Point estimator. Point estimator refers to a sample statistic such as sample mean, sample standard deviation, or sample proportion. The numerical value of the estimator is called the point estimate. Confidence interval estimation refers to an interval of values computed from the sample data that is likely to contain the true value of the population parameter. This can be obtained using the formula point estimate positive negative margin of error, where margin of error equals ZC times standard error of a particular statistic. ZC equals critical value of the standard normal variable. The level of confidence is symbolized by 1 minus A multiplied to 100%, where A is the area in the tail of the distribution outside the confidence interval.
Confidence interval for estimating the mean known. The formula is x bar positive negative z sub a2 sigma over square root of n, or x bar minus z sub a2 sigma over the square root of n, or greater or less than the mean x bar plus z sub a2 sigma over the square root of n.
The value of z needed for constructing a confidence interval is called the critical value for the distribution.
In the table below shows the most common used confidence intervals. As you can see in figure 1, it shows a normal curve associated with 90% confidence level have a critical value of z sub 0.05 is equals to 1.645. While in 95% confidence interval, it has a critical value of z sub 0.025 is equals to 1.960. In confidence level of 99%, it has a critical value of z sub 0.005 is equals to 2.576.
We have here the example number 1. A survey of 40 households found out that the mean age of koron, or the cooking pot that is made of clay, is 3.5 years. Assuming that the standard deviation of the population is 0.5 year, find the best interval estimate of the population mean and the 95% confidence level of the population mean.
So we have the given x bar, which is 3.5, or the mean age of Guron. We have the standard deviation of population, which is 0.5, and the n is equals to 40. So let's distribute the values given in the formula. 3.5 positive negative 1.960 multiplied by 5 over the square root of n, which is 40, is equals to 3.5 point estimate positive negative 0.15 margin error. So we have 3.33 greater than the mean or less than 3.65. So this means that with 90% confidence level, we can conclude that the mean age of Guron is between 3.35 and 3.65 years based on the 40 households.
Confidence interval for estimating the mean. There are times that standard deviation is unknown distributed. Thus, developing a confidence interval estimate of using only the sample statistic and S is necessary. Fortunately, William Gossett developed t-distribution. T-distribution is a continuous probability distribution whose shape depends on the number of degrees freedom. Degree of freedom refers to the number of values in the calculation of statistics that are free to vary. Confidence interval to estimate the population parameter when population standard deviation is unknown and the population is normally distributed.
We have the formula x bar positive negative t sub a over 2 n minus 1 s over the square root of n, or you can also use the formula below.
And lastly, the example number 3. A recent study of 25 students of the University of Antique revealed that the mean time engagement in their online class is 20 hours a week. The standard deviation of the sample was 3 hours. Find the 95% confidence interval of the true mean.
Using the table of t distribution, we will be looking for the value of t using df equals to n minus 1, where n is 25, so minus 1 is equals to 24, and 95% confidence level, two-tailed.
Substitute the given values to the formula. So we have 20 positive negative 2.064 multiplied by 3 over the square root of 25. So 20 positive negative 2.064 multiplied by 3 over 5 is equals to 20 positive negative 1.24. So 18.76 is greater than the x bar or less than 21.24.
Now let's proceed for sampling and sampling distributions. For sampling, generally, it is impossible to study the entire population. Researchers typically rely on a sample to obtain the needed information or data. Sampling technique is procedure used to determine the members of a sample. Sampling frame is a list or set of elements belonging to the population. In determining the sample size, we have to use the Sloven's formula, wherein the sample size is equals to population size over 1 plus population size times desired margin of error squared. According to Gay and Mills 2016, the larger the population size, the smaller the percentage. If the population size is 100, the survey entire population. And if the population size is 500, the survey was 50%. And if the population size is 1,500, 400 will be the sample size. Methods of selecting samples or major sampling techniques. For a probability or random sampling, the population is given an equal chance of being selected in the sample. For non-probability or non-random sampling, not all are given a chance of being included in the sample. Second is systematic random sampling. Samples are selected by using every individual from a population. The first individual selected is a random number between 1 and k. Common methods of probability sampling. Simple random sampling, giving each sample unit an equal chance of being included in a sample. Example was fishbowl or lottery methods and table of random numbers. Third is stratified random sampling. Separates the population into non-overlapping groups called strata and then obtaining a simple random sample from each stratum. It includes proportional allocation and equal allocation. Fourth is cluster sampling. This is sometimes called area sampling because this is usually applied when the population is large. The last is multi-stage sampling. The sample is randomly selected through 2 or more steps or stages. Common methods of non-probability or non-random sampling. First is haphazard or accidental sampling. Samples are picked as it comes to the researcher. Second is judgment or purposive sampling. The samples are selected by the researcher subjectively. Third is convenience sampling. Selecting a sample based on the convenience of the researcher or using data from population members that are readily available. Last is snowball sampling, a special non-probability method used when the desired sample characteristic is rare. Sampling distribution. Sampling distribution refers to the distribution of a sample statistic, such as the mean for all possible samples of a given size n. Important points to consider when collecting data. If measurement of some characteristic from people are being obtained, better result will be achieved if the researcher does the measuring. Choose a method that would not produce a low response rate and ensure that the sample size is large enough. On the other hand, the sampling error is the difference of the sample means and the population mean. Central limit theorem. This theorem states that regardless of the shape of the distribution of the individual values in the population, as the sample gets large enough and greater than equal to 30, the sampling distribution of the mean can be approximated by a normal distribution.
Using our previous data, the mean and standard deviation of the population and the sample means are as follows. So the difference in the standard deviation sub x bar and the standard deviation over the square root of n is due to several factors like sample size, rounding errors, and the shape of distribution.